Continue?
Yes, we hear you.
Yeah, okay. Okay, this is our 5G and 4G's network architecture. Actually, it's similar. It's similar, and the differences is in core network. Core network. Mm-hmm. Mm-hmm. This is for control plate. Control plate. For this is the user plate. User plate. User plate, and this is control plate and user plate. User plate. User plate. This is UE. UE. And for 4G, 4G is for MME and IP transmission to the node B is a control plate, and user plate, user plate. This is the 4G and 5G's network architecture, and the difference is in core network. Core network. 5G, all elements or network elements convert into function like AMF, UDM, UPF, like the AUSF, like PCF in the function. But for the 5G, for the 4G, just MME control plate and P gateway and S gateway, S gateway. Let's get away. And or 5G core network, the core network function also very programmable, flexible. Next I will introduce. You can select the function that you need to match the service. This is a service-oriented core network architecture. It means that or this core network can accept all network, all kinds of access, radio access, like 2G, 4G, 3G, 5G, like NB-IoT, and some low LPWA, low power widely airs technology, and it can also accept different network, and it can also provide all kinds of service like the voice communication, video service, auto pilot, and industrial manufacturing, and smart city, and telemedicine. And for example, for the video service, we need a more bandwidth, high throughput. For the autopilot, automatic driving, we need a low latency. And industry manufacture, we also need low latency. And so different types of network, different types of service may need different features of network, need a different function of the network. So for 5G network, or a network function or capability is flexible. Or network is flexible, and it can be programmable, depend on your need, and we can combine different capability, to into smart pipe, in smart pipe. For example, we just need the UPF provide the EMBB scenario as a service. We just need the UPF. We don't need the AUSF. The security is not very important, so it can reduce the cost, and it's very easy and very flexible. And we can combine some of the function to for one slice. This slice can support one types. Support one types service. So we have flexible architecture and a very flexible capability for different types of slice. And CUPS means control plane and the user plane separation. We can separate the control plane and the user plane, and the user plane deploy is very flexible. Later I will introduce in detail. And SBA service based on the architecture. Our network architecture is based on the service. You have this kind. If you have this kind of service, you need some of this component, and you have some other type of service. We have another types of combination or architecture. This is SBA, depend on the service. And the slice, and by slicing, we can cut our physical network into different slices to support different service to the different user or different customer, like voice communication slice 1, video service slice 2, and automatic driving slice 3, and industry manufacture slice 4. So this is the slicing. It's very flexible. And native cloud. Native cloud. Native cloud means based the core network based on the cloud. The network core network also can be flexible because it depends on IT infrastructure. And why network slicing is required in 5G? Why? First, let's look at our 4G. This is a 4G network. We may have different types of service, like mobile broadband, like automatic driving, like NB-IoT, like intelligent meter reading. There are three very different types of service, and we say this one we need a very low latency. This one we need a very larger connection. And but the 4G is just one 4G network provides service to this service, and they have the same performance. In fact, this 4G or LTE network can adapt to all service because it doesn't have this kind of capability to cut the network into different subnet and provide different capability to different service. You know, our 4G network is dependent on the QoS. QoS is the child-blessed network. Sometimes if the traffic is very, very heavy, the service can't be guaranteed the rate, can't guarantee the ping rate, can't guarantee the latency. This is the 4G network shortcoming. But for 5G, we also have three. But for 5G, we have also three types, like EMBB, like UILC, like MMTC scenarios. And this is the one physical network. We can cut the resource into different peaks. Each piece just one slice. Slice 1, slice 2, and slice 3. Mobile broadband slice 3. One slice is IoT, another is UILC, another is EMBB. They are composed by different function. By different function, so that they can achieve to adapt to different service types. So this is why we need a slicing. We can first we can utilize our network resource. Another, we can guarantee the service to the different user. This is the first point. This is first point. And second is that we can also provide service to different subscribers, to different clients. And we said 5G can enable industrial digitalization, and there may be more and more enterprise subscriber. Maybe one enterprise subscriber just use one slicing for a group of users. So why we need the network slicing in 5G? So you know the user need to have different requirements. Like in factory, like in social media, like the common user. So different user have different requirement. So 5G can depend on the different users' requirement to cut the slice to meet the requirement. This is the slice. Why network slicing is required. Only 5G can
Excuse
support
me?
this service. Please.
Yes, mean that the update version of a quality of service is the number of slices in 5G, right?
You mean numbers of slices in 5G?
No. The update version of quality of service in 4G lead to
quality of the service. QoS.
Lead to the number of slices in 5G.
You mean how many slices can be supported in 5G?
Three slices, right? Or more?
Not three. Multiple.
Depending on application.
Yeah, one for example, for EMBB scenarios, you can support multiple service, multiple slice to the different user, multiple, not only three.
Okay, so what's the difference between quality of service and the number of slice?
QoS just kind of guarantee the service, kind of guarantee the latency, kind of guarantee the ping rate, but our 5G slice it can guarantee the rate, guarantee the latency. Yeah, this is the difference, big differences.
So you mean if I improve the quality QoS, so that no need to go to 5G.
What don't go to 5G?
I mean, if I improve the QoS, so that no need to go to the 5G.
I have said the QoS 4G network, if the traffic is heavy, it can't meet the requirement. If one user need the EMBB bigger bandwidth, if in the heavy traffic, the user may have enough the bandwidth or can't guarantee the rate in your 4G. But for 5G, if you have by the slice and the ping rate and the latency is ensured, can be guaranteed. This is slice. So 5G network can be used in vertical industry, but 4G can't, because it's not very stable, not very latency kind of meet the requirement.
Excuse me.
Please.
Okay. Just one question, please. If the user want to use more than one service, for example, what the scenario will be?
The scenarios.
Use if you want to use two services at the same time.
You mean the slides have any scenarios to realize?
No. Maybe just example, you want at the same time use MBB and URL at the same time.
Yeah, can be realized at the same times.
So he used two slides at the same time? Two slides at the same time?
Yes.
This is possible.
Please just I repeat the same question in another way. How many slices can be for, you said different users, different requirement. So how many slices can any user can be used? For example, how many slices I can be shared with it as a user?
Depend on the configured by the operator, and also, if you pay more money, you can get more slice. The physical network can be cut into multiple slices, many slices. Yeah.
Okay, I think we don't have a limited number of slides. It's depends on application. This depends on application. We don't have a number. It's unlimited number of slides. This depends on application.
I think so. I think each user can support or share 8 slices only.
8 slices.
Yes.
Well, why this number? Why this 8? I think unlimited number. Yeah.
I think some sources or references said just any user can just participate or sharing 8 slices.
Can share 8 slices. You said one user can share the 8 slices.
Yes, for 8 different requirements.
Oh, you get the information from the internet?
Not just from one reference talking about 5G.
Yeah. I'm not sure. Actually, the slicing function can be realized, but the commercial use didn't realize now.
Excuse
clearly,
me.
Yeah.
Yeah, I just want to give. I don't have a question. Just I want to give clarification on the number of slices. Usually, we have some functions within the smartphone, within the terminal. One of them is network slice selection assistance information. So in this model, a list of slices will be predetermined. So how many slices that the user is registered is subscribed, and it can be shown in the NSSIA. So and also, if for example I want to subscribe for IMSI, I mean the SIM card, and also at the same time I want to subscribe for internet, because I just want to use internet and also for example the SIM card. So I will register for a slice. The slice name is the EMBB, and we have 2. There is a keyword which is called DNN, data network name. So DNN1, it is just specified for the SIM card, and DNN2 is specified for the internet. So the number of slices, and also there's also another concern regarding slices. Nowadays, people are working on it. Dynamic slice allocation, for example, for autonomous vehicle. So in autonomous vehicle, yes, we need ultra reliable and low latency, but in 24 hours, we don't need ultra reliable and low latency. So dynamic resource allocation per slice, it's nowadays a very very promising field, and many people are working on this, because sometimes when I park my vehicle at home or in my office, and 8 hours I will be in the office and my vehicle is parked, so I don't need 1 millisecond latency and ultra reliable communication. So these are the things. So, and there are many functions actually at the core network. Slicing, it's because resource allocation per slice, it's a really very broad topic. And there are many functions within the smartphone and many functions also within the core network. And all of them are responsible to provide and allocate resources for each slice. Yeah.
Actually, you are right. You're right. Yeah. Actually, in our 4G, our 4G, there are also two networks. One is VoLTE. Another is our internet. We in our VoLTE, it uses the EPC plus IMS. When we make a call, with some other people, at the same time, we can also access the internet because it have two subnetwork. So I think slicing is similar to if like the VoLTE, like the internet, like the terminal access the internet. If when we make a call with my friend, we can also access the internet, surf the internet at the same time. Actually, it's one slicing one, slicing two. It can be realized at the same time. But for like our 5G, I think it's similar to this situation. They can realize at the same time. One terminal, maybe slice 1, slice 2, slice 3, maybe possible. Yeah. Please, have any question?
No, thank you. But if you come back to the one reference about the 5G, he say up 1 million potential slice.
Yeah.
In this case, we don't have a limited number of the slice. It's a limited number of slice. Yeah.
Yeah, I agree. Yeah, actually, in terms of the number of slides, it's not pretty. Only ITU. In ITU recommendation, they mentioned that we have only three standardized slices, because we have standard slices and also non-standard slices. So the standardized slices is EMBB, URLCC, and also massive machine type communication. So because there are many terminologies like STT, DNN, and NSSI. These terminologies are all of them are just for allocating the resources and providing resources. So also we have non-standardized slices. So in non-standardized, for example, I want to provide smart street light, for example, smart street light. This one is not defined by ITU recommendation. So this one is, we need to assign a specific ID, which is called SST. Yeah, so, there are many details. Yeah, thank you.
Okay. You mean ITU only define the 3 slices, slice 1 for EMBB, slice 2 for URLC?
Yeah, 3 standardized slice. It's defined by ITU, and based on the triangle, massive machine type communication and broadband, enhanced broadband, and the other one is ultra reliable and low latency. So these are the standardized slices, but we have also non-standardized slices. So it depends, as I said, this is very important point. Dynamic resource allocation for slices. Actually, as I said, in autonomous vehicle, I don't need, when I'm parking my vehicle, why I need 1 millisecond latency? Why I need ultra high reliable latency? So dynamic resource allocation within the core and access network, it's a very hot research topic and very challenging. Yeah.
Yeah. Okay.
Yeah,
okay. After class, I check again. Okay. Very good. We can discuss. because the slicing also many customer or many instructor also focus on it because but now slicing not realized actually. So we just because as a network just deploy right now. So many applications not didn't realize. Okay, let's continue. Continue. And through to realize the slicing of a core network function is programmable or network function is programmable. You can see there list some functions which are programmable. The blue color, this blue color for user play, like the coder for video, like decoder or coder for video, like encryption. These functions used for user play include the web acceleration, like a TCP downloading for downloading. And another is for control plane. Control plane. For example, for the registration. If we want to access the network, first we need a registrator. And mobility management, like update, like handover, TAU, and so on, and security, and the QoS, and authentication. These functions are used for control plane. So there are different functions that are programmable, and we can deploy these functions to core network. You can see this network. We can have this HDC, local DC, and central DC. This means data center. The data center just that we have some equipment room. There are many servers inside. The HDC is near to the site, near to the user, near to the base station. And the local DC usually just in one city. And the center DC is in the capital of one region, two province, and so on, like those things. Central DC are usually deployed in one big city. And look like one example. And voice slicing. And it needs reliability, and security and QoS. So the functions were deployed near the terminal. But for IOV, also need the reliability. Need the latency. The reliability. These functions deploy in the HDC near the car. So the delay will be small. And for the eMBB 4K videos, we can deploy the video optimization in the local DC. So if the terminal visited the server is very near, can reduce the latency. Compared to 4G or 4G, maybe the user plane in the core network in the center DC. So if the terminal visit the central DC is very far, it may cause the delay. But for our smart meter reading, this slice, this slicing, this intelligent meter reading don't need didn't need the delay low latency. So yeah, we can deploy the user play in the center DC. It can reduce the cost. Different service can be different service can be configured by the requirement. So we say that core network can be programmable. Some service maybe we just need a coder, or we just deploy the user play. Some service that we may just need is very sensitive security. So we deploy the authentication and the security. So it can different slides can select the different function. This is and the next is CUPS. CUPS. CUPS means the control play and the user play separation. C means control. U means user. P means the play. S means separation. And it means that the control play and the user play can be separated, deployed. And the left side is the structure for 4G, and the right side is structure for 5G. This is 4G. 4G. This is 5G. 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 And let's say if we want to download some video, if is terminal UE. UE. If we want to download some video, this is a video. This is a video here. That's a video here. Video, and then it goes through these two network to the video. UE goes through the base station, IP transmission, core network to the video server. Video server, and then come back to the UE. Come back to UE. It needed to travel through the entire network, whole network, and this may bring more delay. No matter what kind of the service, the video or some driving or some other different service. Because the application is at the core network, at the core layer. All application at the core layer. So there is far distance. It's easy to cause delay. And let's say our 5G the CUPS. If the UE wanted to visit the video server, which is the CDN content delivery network, the UE just need visit the local DC, and they come back. We can say is very compared with the 4G, is very near than 4G. We just with the local DC, because the video just store in the local DC in the CDN. So we just UE can visit here, visit here is very near, and it don't need to go through all network. It just with the local DC can reduce the latency. And if you want to have another kind of application, application layer server can be deployed near the base station, like the V2X. V2X. You can deploy the server near the base station, access the server directly, and compared to this one, your access server is like this way, and the access server is much nearer. It can reduce the delay. So this is our user play in the near the base station, and the control play doesn't matter in the core layer. We don't control play not very is not very sensitive delay, so it doesn't matter. You can deploy in the core network. So this is the CUPS. And for MEC, the CUPS sometimes can be realized by the MEC. MEC means the mobile edge computing. So different service may have different MEC, like video optimization, like IOV, like IoT, and so on. And AMEC, edge computing means means deploy on a server at the edge or at the aggregation. Can be deployed in the aggregation or access layer. This is to reduce the latency. Secondly, can serve the bandwidth. So there are three types of MEC scenarios. First one for the application localization. The first one. Application localization is for more security issue. For some information is very sensitive of the security. It's not sensitive. It's not able to go through the public transmission network, core network. So it just deployed in customers' campus. So the data don't need to go through the public network because of the security. So for some enterprise, they may want to have their information locally decoupled. And so for some second, for the content realization, usually it's just for some resource. Most of the case, video resource, like CDN, is to serve the bandwidth. You can see we can put our resource. We can deploy our video server in here. CDN resource over here. This just for CDN. When the download moving, it's just this way. Download the CDN. Download the movie just this way. Downloading the movie. No need to go through the core network. Because the video often is very big. Maybe 100 or even 1 gigahertz Mbps. And if so, it can serve the bandwidth of the connection between the aggregation layer and the core, because the video is distributed in the local DC. It can serve the bandwidth. So this is the second one, and the third one is the edge computing. And computing means do some process. For example, augmented driving, automatic reality, AR, and Internet of Vehicle, and some other application sensitive delay. This is one need for fast responding. We deploy the server near the user. It needs low latency. In this case, we put this application server near the user. It can lower the latency. So this is about the scenarios of the edge computing. Maybe I think MEC this will be popular in the future. Anyway, because every customer, especially enterprise customer, don't want their data go through the public network because of security. So they will build their own data center near in his campus, in their campus. Okay, have any question? Let's have a short break.